Hello and welcome to Geometry Similarity, Similar Polygons. In this video we will be solving problems using the definition of similar polygons. So we'll be talking about what it means for polygons to be similar, and then using diagrams and descriptions to write similarity statements, using those statements to list congruent corresponding angles, write proportionality statements with corresponding sides, and then we'll be going into finding missing measures, determining if polygons are similar, and solving perimeter problems. These are the Florida B.E.S.T standards that we'll be covering. And so let's go ahead and think back. What are the reasons that we used to determine triangle congruence? So we used side, side, side. We used side, angle, side, angle, side, angle, and then we also used angle, angle, side. And then we had a special one called hypotenuse leg, and that was for our right triangles. So we also talked about some that didn't work. So the ones that we said that we didn't have enough information for was angle, side, side, or side, side, angle. If it spells ass or ass backwards, it didn't work. And then we also talked about how angle, 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 or triple A wouldn't work. And the reason for triple A not working is because if I thought about all of my equilateral, equiangular triangles, okay, all of their measures would still be 60, but then I know that the sides could be different. This one could be 5, 5, 5, and this one could be 100, 100, 100. So even though the angles were the same, the size wasn't going to be the same, and that means that they couldn't be congruent. So that kind of leads us straight into what we're going to talk about in this lesson with similar polygons. All right, and then our second question says, what do we know given this congruency statement? So it says triangle ABC is congruent to triangle DEF, and we talked about how the corresponding angles are going to be in the same position. So I know angle A is congruent to angle D, angle B would be congruent to angle E, and angle C is going to be congruent to angle F. And so if you need to use your pencil or your highlighter to mark these as you go to help you out, make sure you do that, especially on your exam. All right, and then when we look at congruency statements, we can also look at sides. So in this case, I have AB is going to be congruent to DE, and then BC, so if I wanted to mark it, I would do something like that while I'm working on my test. I have BC is congruent to EF, and then AC is congruent to DF. And notice that as I'm writing these down, I'm making sure that all of my corresponding angles are still in the same position. So A is still going with D, B is still going with E. So you want to make sure that those are lining up, especially as you're writing your congruency statements or working with them. All right, so let's go ahead and get into similar polygons. So similar polygons, that is going to be our dilation transformations, and we talked about translations, which is a slide, reflections, which are flips, and then rotations, which are turns. Those are all rigid transformations. The reason why they're called rigid transformations is because the shape is not changing in size. It might be moving around, but it's still going to preserve all of the angles and all of the sides. When it comes to dilations, it's non-rigid because that size is changing. So with similar polygons, they're going to have congruent corresponding angles. And let's go ahead and put that sign there. That way we can kind of remind ourselves of all of our symbols. And then when it comes to the sides, instead of them being congruent, they are going to be proportional. And we do have a symbol for that. It looks almost like an infinity symbol that's not finished. So instead of writing them out, writing out the word proportional, you can use this symbol here. And then it preserves the angles and only preserves the sides when the scale factor is 1. So with our rigid transformations, translations, reflections, and rotations, it was preserving angles and sides. With similar polygons, it's only going to preserve the sides if the scale factor is 1. And we'll get more into scale factor in our upcoming slides. The symbol we're going to use for similar is this, and so that means similar. And if you notice, that same symbol is with our congruency symbol, right? So with congruence, they're saying that it's similar and the sides are equal. Okay, and that's where it comes from with that symbol that we use for congruent. Similar is just talking about those angles and then having those sides being proportionate. Alright, so let's take a look at a similarity statement. So similarity statements are very, very similar to what we worked with before. So we could say angle A is still going to be congruent to angle W, and so forth. But the difference is when we're talking about the sides, so now when I'm talking about AB and WX, my angles are going to be congruent, but my sides are going to be proportionate. And so that's where we're going to use that new symbol. Okay, and so AB would be proportionate or proportional to WX, and so forth. And so just recognize that A is still going with W, B is still going with X, and then we can even add on to more sides, right? C is still going with Y, and D is still going with Z as we make those statements. Alright, and let's go ahead and move on. So now we're getting into determining whether pairs are similar. So the first thing I want to kind of ask myself, if it's not super obvious, there are some things that we're going to kind of assume, but with this one it's giving me all of the angles. So are the angles congruent? That's going to be my first question. And then I'm going to ask myself, are the sides proportional? And we'll get into that in a second. But with this very first one, I can see here that I have 39, 51, 42, and 48, and then those right angles. So these would automatically not be similar. Let's take a look at another one. So looking at this one, we kind of want to think back to some of the things that we did when we were working with congruent triangles. And I noticed that there's a shared side here, so I'm going to go ahead and mark that up. So if you need to, go ahead and write yourself a little note. Mark any shared sides. If you know any sides that are parallel, you could go into marking any corresponding angles, things like that, and then also marking those vertical angles. Those were things that we always looked for when we looked for congruency, and we're going to carry that same thing into similarity. So looking at this one, I'm thinking back to what I remember about congruent triangles, and looking here, when I read this triangle, I have side, and then I have this angle, and side, the angle, and side. So looking at these two triangles, I can see that these are actually congruent triangles. So these are going to be congruent, side, angle, side. Now, when we're thinking about similarity, congruency means the angles are the same and the sides are the same. For similarity, we're still looking to see if the angles are the same. That's true. And then are the sides proportional to one another? And this would be a yes. This is also similar with a scale factor of 1. Okay, so these would be congruent and similar. And that scale factor would be 1 because if this side was 5, I would multiply it by a scale factor of 1 and I get 5 still for the other triangle. Now let's determine if these figures are similar. So looking at just the angles, all of them are right angles, and so all the angles are the same, so that checks out. But now I have to see if those sides are proportional. Now looking at these, notice that I have a shorter side and a longer side, and then this one, shorter side and longer side. We don't have a similarity statement or any kind of statement to go off of, but I kind of want to make sure that the same things go with the same thing. So now I can write this as 2 goes with 8 and 4 goes with 10 on my other one. So notice how I did that. And then I could have also, because there's only 2 sides that I'm working with, I could have also written it as 2 goes with 8 and 4 goes with 10. When you're only working with 2, I could have one shape here, so shape 1 on the top and then shape 2 on the bottom, or I could have put shape 1 on this side and shape 2 on this side if I'm only working with 2 different side measures or pairs. So now from here I'm going to determine whether these are similar. So I set up my proportions, and just keep in mind that they may also use the actual side names. So they might say something like MN goes with GH and NP goes with HJ. Okay, and it doesn't matter which shape you put first, you might also do it the other way around. So these could be on the top, so just kind of keep that in mind. Alright, and so now from here I'm going to put this into my calculator. So I can put 2/8 into my calculator and I end up getting 0.25 or 1/4. And then for this one, I can put this into my calculator, and 4/10 is going to be 0.4. Notice that these are not equal, and so this is going to be not similar. Okay. The same thing I would have done for this one as well. I would have gotten the same thing. I would have gotten 2 decimals that didn't check out. Now, there's another way I can do this. I can also cross multiply. 2 times 10 gives me 20, and 4 times 8 gives me 32, and those are not equal either. And so neither one of those would work. And then notice on this one, I would still have the same numbers being cross multiplied, and that's why both of these end up working out the same way. Let's go ahead and try this with another one. So this one we have some fractions going on here, and it seems like a lot. Okay, so what I'm going to do is I'm going to first look at my angles and see if I have the same measures. We talked about marking any shared sides or vertical angles, so go ahead and mark those two up. I have a single marking, a double arc mark, and or arc marks, and then I have my right angle, and then I have the same markings on my other triangle, so the angles check out. I'm going to write a preliminary similarity statement to kind of help me out with making my proportions. That way I'm not messing anything up. So I have triangle BCD is similar to triangle, and then I want to make sure that I'm putting the same markings. So notice that B and F have the same marking, C and C have the same marking, and then G and D have the same marking. And that just makes it to where even if they kind of turn something, I'm not marking the wrong things. Alright, so I have my little preliminary statement, and I kind of want to see if this is true. So I'm going to write out my proportions. So with this one, I'm going to put the first shape on the top and put the second shape on the bottom. So I'm going to put BCD on the top and triangle FCG on the bottom. Okay, and so now I have B, right? So BC is 5, and that goes with FC, which is 25 over 3. And then I have 4, which is BD, going with FG. And then I have 3, which goes with 5. So cross multiplying when I have 3 fractions might be a little bit difficult, but I can still just put these fractions into my calculator. So when you go to put this in the calculator, what you're going to do is you're going to say 5 divided by, and then we want to put that fraction in parentheses, 25 divided by 3, close parentheses, and then always make sure you hit equals, because what it's going to do, it's going to show you 25 divided by 3, because that was the last thing we put in. It's going to show that here. So you always want to make sure you press equals, and we get 0.6 for this one. And then when we put this one in as well, so make sure that you're putting 4 divided by parentheses 20 divided by 3, and then make sure you hit that equal sign at the end. This one also gives us 0.6, and then 3 divided by 5 also gives us 0.6. And because all 3 of these are the same, this checks out. If any of these were different, then that would be not proportional. And so these two are similar. The angles are the same and the sides are proportionate. So now that we know how to set up our proportions, we can also use that to start finding some unknown measures. So like this one, it's automatically telling us that our polygons are similar, and they're asking us for the value of x. So make sure that you go ahead and write yourself a little proportionality statement or similarity statement. And so we have W is similar to S, and then we have V, because I always want to travel in a circle going around. I don't want to skip anything. We have V going with T. We have our next right angle, so Z goes with Q. And then we have C is going with P. Both of those are unmarked. And then we have our singular arc mark. We have J and R. So just kind of keep in mind that these shapes, they're not always going to go in alphabetical order. They can start with any one of these as long as it's traveling in that circle around the shape. So just kind of keep that in mind. So if you wanted to start with J and then W and then V and go so forth, that might be a little bit easier for you. All right, so now from here, I know that WJ, because I want to use the sides that they're giving me, WJ is between that 1 and 2 arc mark, so it's going to go with this side here. And this just kind of helps with making sure that you're not putting the wrong things with the wrong things, especially as they start turning and flipping some of these polygons. So we have WJ goes with S, R. So WJ is x plus 1, goes with 8. And then we have JC. So JC going with RP, which is 20. So we have 3x plus 1 going with 20. And then from here, we can't use our calculator, obviously, to throw these in and see if they work. So we're going to cross multiply. Now, whenever you're cross multiplying, when you have more than one thing in the numerator or denominator, go ahead and throw those in parentheses. So now when I go to write this, I'm going to say 20 times x plus 1 equals 8 times 3x plus 1, and then I can distribute and solve for x. And for this problem, I got x equals 3. Then you may want to go back and reread your question, especially if you're taking a test, because sometimes the question, instead of asking for x, they might say, hey, what is JW? And so JW would be x plus 1, and we found out what x was, and so that would be 4. So now let's get into the next one. So notice that this side is put between the two markings and this side is put between the two markings. So with this one, we're going to go ahead and assume that these angles are going to be congruent. They already told us that the polygons are similar, and so they marked it just enough for us to make the assumption that MP is going to go with WZ. And so from here, I know that 8x minus 1 goes with 12, and then my 3x minus 1 goes with 4. And then I'm going to put my parentheses and cross multiply and then solve for x. And so once I solve that out, I get x is equal to 2, and then if they ask me to plug it back into one of these, I would find out that MP is 15 and PR is 5. Now let's get into one of our word problems. So in a video game, the user navigates through an unknown land using a map. On the map, the distance between the character's home and the store is 2. The distance between the store and the dungeon is 8. And the distance between the dungeon and the character's home is 7 centimeters. So I'm going to start, and while I'm drawing, if I notice that I might need to change my shape or something like that, I can always change it later. So it says from the character's home to the store is 2 centimeters, and then from the store to the dungeon is 8 centimeters, and then from the dungeon back to the character's home is 7 centimeters. When I'm drawing this, I know that this isn't going to be a right triangle, but none of that really matters because as long as it's representing what I need it to represent, I'm okay. And then they said if the actual distance, and so we're talking about a scaled copy of some sort, and so his real home, the real store, and the real dungeon I'm going to put as home prime, store prime, and dungeon prime. And now I have the actual distance between the store and the dungeon is 4 kilometers. And then it says how far will the character have to travel if the game to visit all 3 destinations and return to the starting point. So that means they're starting off at home maybe, and they're going to all 3 and then going back home. Well, that's perimeter, okay? And so they're asking for the perimeter of the actual distance. And so not even having to do a whole bunch of work, I'm going to think, how would I go from 4 to 8? Well, I would multiply by 2. So to divide by 2, I say 2 divided by 2 would give me 1 kilometer. And then 7 divided by 2 would give me 3.5 kilometers. And then if I add all of these up, 1 plus 4 plus 3.5, that gives me 8.5 kilometers if he started at 1, went to all 3 destinations, came back. And so 8.5 kilometers would be my answer for that one. Alright, looking at this one, Naya's rectangular lawn, so I'm going to go ahead and draw a rectangle, has a perimeter of 126 meters, and the ratio of the length to the width of the lawn is 5 to 2. Well, if I'm making a scaled copy and if I was drawing this on maybe graph paper, I would put 5 by 2. I'm just going to go ahead and make that the dimensions of my scaled copy. And then we're talking about perimeter. So I'm going to find the perimeter of my scaled copy. And I have 14 for the perimeter of this one. And just to kind of think about what this looks like, if I have a 1 by 1 square, right? And then I have a 5 by 5 squared. I'm doing 1 times 5 to give 5. 1 times 5 to give 5, right? If I'm thinking about perimeter, it's going to be the same thing. I'm going to have 4 of these times 5 is going to give me the same as these times 4, right? And so now I'm going to think, how do I get from 14 to 126? Well, I multiply by 9. And so for her real lawn, we're going to multiply each one of these by 9. So 2 times 9 gives me 18. And then 5 times 9 gives me 45. I would check that in my calculator, and this does end up giving me a perimeter of 126. Now I want to make sure I go back and read my question. It says, what is the width of the lawn? And so remember, it said for the length to the width is 5 to 2. So we want to make sure that we're still talking about the width here, and that would be 18. And so my answer would be 18 meters, and that concludes our video on similar polygons.